Hi everyone, welcome to Graphing Inverse Functions the Easy Way. So in math, there are always many ways to do something. However, there is always a most efficient way, and that's what we're going to discuss today as far as how to graph these inverse functions. Our learning goals for today, we're going to learn how to graph the inverse if given a graph or if given an equation. So you have the graph and you're asked, hey, find the inverse of this. Or you're given an equation and you're asked, hey, can you graph the inverse of this equation on the same graph? And then the second learning goal we'll go over is discovering the relationship of inverses and their graphs on the same plane. And what do these guys look like? So here's the process. And let me switch my pen. So step one, get a table of points for the original function. Like I say over and over and over again, a table will always work to graph. So we have some original function here. We've plugged in a couple x's and we've outputted a couple y's, right? Whatever our function is, like in this case, we plugged in -2 and we got -3. In this case, we plugged in 0 and we got out 1. We plugged in 2 and we got out 5. Okay, so get a table of points for your original function, either by plugging them in, or if you're given the graph, pick out some of the points on the graph. Like for instance, here's 0, 1, here's 1, 2, what else we got? Here's -1, -1, here's -2, -3. So you can either pick out the points off of your graph, or plug in a couple of random x's and get some y's out. Okay, so first step, build yourself a table of points for the original function. And then step 2, in order to get the table of points for the inverse function, since the inverse is just switching the input and output, so x goes to y goes to x. In other words, just switch these guys around. So instead of -2, -3, we'll have -3, -2. So switching everything, -1, -1, switch it, 1, 0, switch it, 3, 1, switch it, 2, 5. Sorry, 5, 2. So to get the inverse table, because the way inverses work, inputs become outputs and outputs become inputs. We're just going the opposite direction. So you get your table of values for your inverse, okay? And then step 3, just graph. So -3, -2, -3, -2, -1, -1, 1, 0, 3, 1, and 5, 2. Draw your lines, and there it is, your function and your inverse all on the same graph. That's it, super simple. I'm a huge advocate of graphing via a table, especially if you're not sure. Otherwise, we have to go through like, oh, this is a parabola, where's the vertex, where's, the line of the axis of symmetry and all that. No, just make the table and then make the inverse table. So here's an example. So graph this inverse. We're not given the function, we're just given, hey, here's a set of points, now graph the inverse. Okay, well, how can I do this? Well, let's look at our x and y pairs. Okay, well, this point right here is the point 2, 5. Okay, this point right here is the point 1, 2. This point over here is the point -1, 3. And this point over here is -2, 4. -2, 4. Okay. Well, what about what we want? So now inverse it. So switch your x's and y's. So now my new x will be 5, my new y will be 2, my new x will be 2, my new y will be 1. Then switch, then switch. Okay, now graph. Now we graph the point 5, 2. 5, 2 is here. We graph 2, 1, which is here. We graph 3, -1, which is here. And 4, -2, 4 is here. -2 is here. Done. So again, steps, get a set of point for the original graph or / function, and then inverse it, switch all the x's and y's because inputs become outputs, outputs become inputs, and then graph your new table and done. So this guy is finished. We graph the inverse there. Okay, what if you're given a more complicated graph as so? Well, same thing. Let's pick out some points on this graph. We'll switch them and then we'll graph the new points. So let's see what we got as far as a set of points here. Okay, it looks like we touched down here, which is the point 7,5. Let's see, we're just looking for nice points. Here's a nice point, that's 0,4. This looks like a nice point here, that's negative 5,3. Let's see, keep going. That looks like a nice point. We're just looking for nice grid points. Negative 8, 2, negative 8, 2. This is a nice point here, negative 9, 1. And then coming around the other way, negative 8, 0. What else do we have? Negative 5, negative 1. 0, negative 2. You can start seeing that these are all reflections. And 7, negative 3. Okay, so I pulled out a table of points. Next thing I'm going to do, I'm going to construct my inverse table. So my new x and my new y by just flipping my old x and y. So that's going to be 5, 7, that's going to be 4, 0, that's going to be 3, negative 5, that's going to be 2, negative 8, it's going to be 1, negative 9, 0, negative 8, negative 5, negative 1, negative 2, 0, negative 3, 7. Now let's plot all these and we'll have our inverse on the same graph. So 5, 7, 5, 7, 4, 0, 3, negative 5, 2, negative 8, 1, negative 9, 0, negative 8, negative 1, negative 5, negative 2, 0, and negative 3, 7. Okay, now I'm going to try to draw the line through these as best I can, but you guys are about to see exactly how challenging this is. Oh, 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 we got a little skewed there. Oh, come on. And boom. Actually, one of my better graphs. So, this kind of pinkish looking graph and the black graph are inverses each other. Again, all we did is switch the inputs and the outputs. Get a list of x and y's, flip them, graph them. That's it. Get the list of x and y's, flip them, graph them. Okay, but what if we don't have our graph already available to us? Oh no. Okay, well, we know how to graph. So, x, let's get some x and y's here. Right, let's do our old faithful, negative 2, negative 1, 0, 1, 2. We'll just plug them into the function and we'll get some outputs. So negative 2 plugged into this function is going to go to negative 7. 2 times negative 2 is negative 4, minus 3, negative 7. Plug in negative 1. 2 times negative 1 is negative 2, minus 3 is negative 5. Plug in 0, we get negative 3. Plug in 1. 1 times 2 is 2. 2 minus 3 is negative 1. Plug in 2. 2 times 2 is 4. Minus 3 is 1. Now let's graph those. Negative 2, negative 7, negative 1, negative 5, negative 1, negative 5, 0, negative 3, 1, negative 1, 2, 1. Okay, let's draw a line between these as best as I possibly can. This is supposed to be a straight squiggle line. Okay. So there's kind of the function 2x minus 3. Now let's grab the inverse function. So inverse it. The inverse then, switch all the x's and the y's. So we'd have negative 7, that's a 7. -2, -5, -1, -3, 0, -1, 1, 1, 2. Alright, -7, -2, -7, -2, -5, -1, -3, I almost said -0, -3, 0, -1, 1, and 1, 2, 1, 2. Okay, drawing your best straight line as you possibly can. Hey, this one came out a lot better. There we go. Alright, there's your graph and your inverse graph all on the same plane. Again, get a list of points for the original graph, inverse them, switch your inputs, switch your outputs, graph the new points, done. So now, saying all that, what can we figure out is the relationship between graphs and their inverses? So we have a graph and its inverse here, a graph and its inverse here, a graph and its inverse here, graph and its inverse, graph and its inverse. So if you kind of look, take a couple of seconds and kind of see if you can see what's going on here. These are really interesting. So pause if you want to figure it out on your own. I'm about to give it away. Spoiler alert. Graphs and their inverses. Graphs of inverses reflect over the line y equals x. Y equals x is just a diagonal. That's the relationship. Inverses reflect over the line y equals x. The line y equals x is what you see here. It's this diagonal. In other words, that's like the mirror line. Across this line, the function and its inverse are perfect mirror reflections of each other. This is also the reason why we switch the x and the y. And reflections, when you switch x and y, what you're doing is you are reflecting over the line y equals x, right? Because we're just trading out x for y. So that was the big kind of reveal of the whole thing. Functions and their inverses reflect over the line y equals x, or think about it as they reflect over the diagonal. So, achievement unlocked. We did indeed learn how to find the graph of an inverse if given the graph or an equation. Get the table of points for the original graph, whether you pull them off the graph or you find them yourself manually from the equation. Switch the x's and y's, get yourself a new table, plot the points of your new table, and you have your graph and your inverse on the same graph. Done. And then the second thing we figured out is the relationship of inverse graphs. Hey, they are reflections over the line y equals x, or they reflect over the diagonal. So thank you guys. As always, if you have any questions, please just ask.